Right, we're going to look at the three types of radiation that you need to know for GCSE. First of all, we'll start with alpha particles. Now, alpha particles is an emission from a nucleus. It tends to be from a very, very big nucleus, and it's a way of getting rid of excess mass rather quickly. So it gets a nucleus will get rid of 2 protons and 2 neutrons and eject it at roughly 10% the speed of light. And what is it made up of? 2 protons and 2 neutrons. It's sometimes described as a helium nucleus, which is correct. It is a helium nucleus. It's missing the electrons, and that's thrown out of the nucleus of a bigger nucleus. So yeah, if you've got a massive atom that's overweight, it can lose weight very quickly by ejecting an alpha particle, or essentially a helium nucleus. The way you would write down an alpha particle is 4,2 with an alpha symbol. Sometimes it's written down as 4,2 He because it's point out it's a helium nucleus, and of course you should know about the notation that we use for writing these symbols down. So 2 refers to the number of protons, and 4 refers to the atomic mass, the total number of objects in the nucleus. Right, alpha particles travel quickly, about 10% the speed of light, as I said before, which is roughly around 18,000 miles per second. They have lots of energy, and the reason they've got loads of energy is they are actually massive compared to the other radioactive particles. They are very, very big, and they move fast, so they've got lots of kinetic energy. They are strongly ionizing. Now, what does this mean? Ionizing means that it has the ability to create a charge on something it goes next to or that it hits. Because alpha is positive, because it's got 2 protons, it can rip off any electrons from any atoms nearby. And if an atom is then loses an electron, it is then ionized. That's what I mean by ionized. It's suddenly gained a charge. And at that point, it will combine with anything else. So it can be quite dangerous. So, for example, it can cause cancers. If you find an alpha particle, let's say DNA, inside the body, it could ionize some of the atoms in there and cause the DNA to start behaving in a cancerous way. Alphas are dangerous if they're breathed in or if you eat them, because they don't travel very far. They can only go through about 5 centimeters of air, or they get stopped by paper, or they get stopped by skin. This does not mean that they're weak. What they're doing is they're wrecking the skin, they're wrecking the paper, they're wrecking the air, they're ionizing it. And of course, if you've got it inside your stomach or your intestines, as the alphas hit the testy wall, they will be killing it, they'll be damaging it, wrecking it. So that's why they're particularly dangerous inside the body. However, outside the body, they like to be stopped by the skin. And of course they're not weak. You need to know how alpha particles behave in an electric field. Now, because the alpha particle is positively charged, it gets attracted towards the negative plate there. You've actually got 2 steel plates, one with a positive charge, one with a negative charge, and the alpha particle gets attracted towards the negative plate. In a magnetic field, what you find is that if an alpha particle enters a magnetic field, it would form a coil like that. It would curl around. It's quite famous there. It behaves totally differently to a beta. The beta particle would coil in the opposite direction. That's the way you can distinguish between alpha and beta. That is, alpha goes one way, beta goes another way. You can use certain scientific laws to work out which one's which, but that is not needed for this course. In the exam, you may be presented with a formula. So we've got a substance here, TL, which I seem to remember, I think is thallium. I'll have a quick check. Yeah, it is thallium. And thallium-81. This is actually, thallium's got 81 protons, 201 neutrons. It normally has 204. But let's imagine it got rid of an alpha particle. You'd find that by getting rid of an alpha particle, it would now become 19779, which is gold. And of course, it would also release gamma rays in a burst of energy. Now, what you need to know for this, for the exam purposes, is that the atomic mass, the number in orange up there, what you had before the arrow, 201, must equal the total after the arrow. So 197 plus 4 must equal 201. And the same applies to the pink thing underneath. So you've got 81 there, and that must equal 79 plus 2 underneath. So what they may often do is they'll put the numbers up there. They'll show 4 and 2, and that should act as a trigger in your mind, thinking, that's a helium nucleus. That is an alpha particle. And very often the question will ask you to guess what, put in what the missing numbers are in an equation. So make sure you know how to do alpha particle equations. Right, the keywords concepts is, first of all, recognise that the alpha particle is a helium nucleus and is written as 4,2 He or 4,2 alpha. Make sure you know how to do the equations of when alpha decays. That's a higher tier question. Make sure you know that it's stopped by 5 centimeters of air or paper. Be aware that it is more dangerous inside the body than outside the body, and also make sure you know how it behaves when it enters an electric field and a magnetic field. And that is everything you need to know about alpha particles.